Okay, here we go. So we're doing the Q3 test review for Precalc. I have it up in Delta Math here. I have the cheat sheet as well. I filled out a copy myself and Desmos just in case. And we got some little scratch area to work on the left here. Let's see. Okay, so the first few we're doing some trig stuff. So it looks like we're doing quadrants. In what quadrant does theta lie if the following statements are true? Cosine is less than 0. So that means that cosine is negative. And sine is greater than 0, so sine is positive. So we're looking for where cosine is less than 0. So cosine of theta is negative. Looking at my little quadrant, my unit circle here, all sine, tangent, cosine, ASTC. Let's see, so cosine is going to be negative in these two quadrants, 2 and 3. Sine is greater than 0, so sine is positive. That would be in quadrant 2. So for my answer, I'll select quadrant 2. Awesome. And guys, don't forget, if you mess up, they show you a description. Read it. Turns out it's kind of helpful. Next one. Okay, so we need tangent greater than 0, so tangent positive. So where's tangent positive? Let's see. Tangent is going to be positive in quadrant 3, quadrant 1. And sine is greater than 0. Sine is positive. Well, sine is positive in quadrant 1 and quadrant 2. So it must be quadrant 1. Excellent. One more like this. Okay, so in what quadrant does theta lie if sine is negative? Okay, so where's sine negative? Let's see, sine is negative. It's going to be in the bottom two. Remember, sine is the y values on the unit circle. Those are negative in quadrant 3 and 4. Okay, tangent positive, so that must be quadrant 3. All right, next section. So I already did one round with this. Going to do it again, though. So we have to get, in 100 seconds, you have to get at least 10 trig ratios. So this one is really just using these first three. Okay, sine, cosine, and tangent. So you just have to be careful about what angle they're referring to and then match it with the correct fraction. Here we go. Sine of A, opposite over hypotenuse. Boom. Sine of B, opposite over hypotenuse. Boom. Tangent of A, opposite over adjacent. Sine of A, opposite over hypotenuse. 84 over 91. Tangent of A, opposite over adjacent. 9 over 40. Sine of A, opposite hypotenuse. 72, 75. There it is. Cosine of B, that's up here now. Adjacent hypotenuse, so 56 over 65. Tangent of B, opposite from B is 24 over adjacent 70. Tangent of A, opposite A is 16 over adjacent 30. Okay, tangent of A again, opposite over adjacent. Tangent of B, I've got 10 out of 10, so I can stop now. Let's do a couple more. Tangent of B, so B is up here. Okay, opposite of B is 24, adjacent B, 18. One more, sine of B, opposite 6, hypotenuse 10. Okay, and that's good enough. Cool. Next section. All right, so this one, again, very similar. This is reciprocal trig now. So we're going to be using the other side. So flipping things over, and this one, it might take you a little bit more, another try or two, but you can do it. Cotangent, let's see, cotangent of A, adjacent over opposite. Secant, hypotenuse over adjacent. 95 over 57. Where's that? There it is. Cotangent adjacent to B, 45 over opposite, 28. Cosecant, that's sine flipped. So cosecant, so hypotenuse over opposite, 58 over 42. Nice. Cosecant of B again. So hypotenuse, 85 over opposite, 84. Notice I'm kind of taking my time here, being a little more careful. Cotangent of B. So that's going to be adjacent, 65 over opposite, 72. Cosecant of B. So we are, again, let's see, hypotenuse over opposite, 89 over 80. Where's that? Right there. Cotangent of A. So let's see, adjacent, 21 over opposite, 28. Cosecant. Hypotenuse over opposite. Hypotenuse over opposite, 85 over 77. And one more, cotangent of A. So here we go. Adjacent, 60 over opposite, 25. All right, that's good enough. Cool. Moving on. Wait a second. We got 10 out of 10, right? Oh, yeah. We're good. Okay. I guess we'll go back and redo that one later. Okay, now we are doing trig ratios. We have radicals this time, so we're going to simplify some stuff. So we have sine of A. All right, let's see here. So sine of A. A is going to be this angle here, opposite. So root 45 over hypotenuse 9. So we need to simplify the square root of 45. Let's do that. So root 45 is what, the square root of 9 times 5? Or 3 root 5. Cool. So I have 3 root 5 over 9. Simplifies to root 5 over 3. Let's see, root 5 over, over 3. Yay, we did it right. Cosine of A, simplest radical form. So cosine, adjacent over hypotenuse. So we need adjacent 4 over hypotenuse, root 65. And there we are with the radical on the bottom. So some people will simplify the radical first and then rationalize the denominator. I like to just rationalize first and then simplify. So I'm going to multiply by root 65 over root 65. Okay, we're multiplying by 1 creatively. So I have 4 root 65 on top. Okay, on the bottom, root 65 times itself is 65. Now let's think about simplifying root 65. So what goes into 65? 5 and 13. Both are prime. Can't break it down any further. So that's it. All right, let's see if we did it right. Nice. Tangent this time. Okay, no radicals. This one should be easy. So tangent of A, opposite, 7 over adjacent, 24. Awesome. On to logarithms. Okay, so I'm going to hop to the next page. We're doing log rules. All right, so these rules up here are going to be really helpful. So we need to do simplest form. All right, so I have log base b of 4 plus 4 log base b of 2. So first off, I see the 4 outside. That's going to come inside. Okay, according to my rules, it comes inside as an exponent. So this is log base b of 4 plus log base b of 2 to the 4th. And 2 to the 4th is 16. So we have log base b of 4 plus log base b of 16. One more rule. When we're adding logarithms, we can condense it into multiplication of the stuff inside. So we're going to say log base b of 4 times 16. And what's 4 times 16? 64. Okay. Let's see if we did it right. Yay. Okay. 2 log base b of 4 minus log base b of 2. Okay, so I have that 2 outside. It's going to come in as an exponent. And if it helps you to write parentheses around the part that's actually inside the logarithm, you can do that. Okay, so we have log base b of 4 squared minus log base b of 2. Okay. So that's what, 16? Again, we have subtraction. So we're going to bring that together, condense it as division, right? It's the opposite of multiplication. So 16 over 2. What's 16 over 2? That's 8. Log base b of 8. All right. One more. Okay, this one should be pretty easy. We have log base b of 9 plus log base b of 4. Bring it in as multiplication. What's 9 times 4? 36. Hey, all right. Another one down. Let's see, exponential and log functions. So this is the one that people seem to have the most trouble with, just because there's a lot of blanks to fill in. And I will say, for some reason, when I'm recording this, it doesn't show the drop downs. I don't know if that's a thing with OBS or something, but you know, that's just an issue. So we'll work through it though. So I'm going to scroll up so we have our little log graphs. So some things to remember. Log graphs always have a vertical asymptote. Okay, so this function, let's see. I know it's logarithmic because it says log base 2 in the name. So we're going to say logarithmic. What kind of asymptote does it have? Logs, always vertical asymptotes. Okay, vertical asymptotes are going to be x equals, and then it's the x value that this vertical line approaches. So it looks like we're approaching x equals 2. Okay, the range, log functions, they point all the way up, and we're going to go all the way down. Okay, so our range is always all real numbers with logs. This is going to be decreasing when it's domain. As I go from left to right, that marble is rolling down the hill. It's decreasing. Domain in this case, so the furthest the left that I can go is wherever that vertical asymptote is. So I can start at 2, right? But then I move to the right off to positive infinity on the x-axis. So my domain is going to be 2 to infinity. For end behavior on the left side, as I come in from the left, I'm going up, okay? And I'm approaching that vertical asymptote. So I'm going to approach 2 from the right. I'm not going to pass that x value. And my y value is going to approach infinity. I'm just going to go up, okay? On the right side, I'm going off to the right forever. So x is going to infinity, okay? And as x goes to infinity, I'm very slowly going downwards. So y is going to negative infinity. All right, let's make sure we put everything in there correctly. Nice. One more. Oops. I already did a couple of these. I might as well do, we'll do one more. Let's see if we can get a, oh, this is fine. This is another logarithm. All right. Logarithmic, I know because it's in the name. Has a vertical asymptote. Logs always have vertical asymptotes. X equals, this time it's around, looks like -7. Okay. The range, again, logarithms, range is all real numbers, always. Going down forever on the left, we're going up forever on the right. It is increasing, we're going uphill this time. Domain, the furthest to the left that I can go is -7. And I'm going to go forever to the right, to positive infinity. Left side end behavior. So as I move in, okay, I'm rolling down the hill, going right to left. I'm not going to cross the x value of -7. And I'm going to go straight down towards negative infinity. Okay. On the right side, I'm going to slowly go up as I move to the right forever. So x is going to infinity. I'm going to the right forever, and I'm slowly moving up. So y is approaching positive infinity. Beautiful. Next section, here we go. All right, so this is function inverses. So there's a few ways to do this. We could find it algebraically. I guess we'll do that for a couple. So our rules, remember, we set y equal to f of x, swap x and y, solve for y. Let's try that. Okay, so set y equal to f of x, swap x and y, solve for y. First thing I'm going to do, I'm going to move the 6 over. Oops. Okay, and then I need to get y by itself, so I'm going to take a 5th root of both sides. Okay, does that match with anything? It looks like it matches with this third option here. Awesome. Oh, look, they show you the steps right here. Let's try another one. So we're starting with 5 root x, swap x and y. All right. Now let's get y by itself. So I need to take care of the 5 first. I'm going to divide by 5 on both sides. So I have x over 5 equals root y. How do you get rid of square roots? Square both sides. So we have y equals, let's see, x over 5 squared. Awesome. Okay, cube root x plus 5. Ooh, that's a fun one. Set it equal to y. And sometimes people kind of skip the first couple steps and go straight to this where we switch x and y, but I like to show that step. I think a lot of people need it. All right, subtract 5 from both sides. We want to get this y by itself. Okay, how do you get rid of a cube root? Cube both sides. Okay, so we have y equals, let's see, x minus 5 all cubed. Okay, one more. Swap x and y. Okay, you could distribute the 6 here. It is kind of tempting, but you don't have to. I'm not going to. I'm just going to divide by 6. Get rid of that. So we have x over 6 equals y minus 9. Add 9 to both sides. So we have x over 6 plus 9. Does that match an answer choice? Looks like it. Okay, I think we're almost done. So here we're identifying inverses graphically. So what this section is all about is the fact that a function and its inverse, their domain and range are switched. In other words, their x and y values are swapped. So it's like we're going to be taking points from the graph on that's already plotted, and then we're switching the x and y values and plotting those new points. Okay. So we've already plotted. We're going to pick some points, swap x and y, and plot those. Okay. So let's see. So what would be a good one here? It looks like here's one. I'm not going to. So that's 1, 4. So if we switch that, 4, 1. Okay. Where does it cross the axis? 0, 5. So that's going to become 5, 0. Okay. 0, 2. So that's going to become 2, 0. Or 0, 3, I'm sorry. Becomes 3, 0. All right, we need to pick 2 more points. So let's, I don't know, find one. This looks like one. -3, +2. So that's going to become +2, -3. And you can kind of see some symmetry here. So we'll go up to, we have -3, 6. So go over to 6, down to -3. Once you plot the 5th point, it plots the graph for you. And remember, this should look like it's been reflected over the line y equals x, this dotted line here. Awesome. They even give you a little table where they switch the x's and y's for you. Nice. Okay. Ooh, this one's crossing over y equals x. Let's see. What would be a good one here? I always like to pick the turning point if I can. So I have -9, -2. So we're going to go to -2, down to -9. Okay. Where do we cross here? It looks like -5, 0. So that becomes 0, -5. Here's another one. -8, -3. So -3. Oops. -8. Two more. We'll also do, let's see, we got -8, -1. Let's do that one too. So -1, -8. One more. 0, 4. So that should be 4, 0. Oh, nope, that's not it. Uh-oh. 0, 1, I'm sorry. 1, 0. Beautiful. So you just got to be careful with this. Just got to be careful. Una más. Okay, here we go. Let's see, we got 9, -5. So -5, all the way up to 9. What else? 5, -3, so -3, 5. We also have 5, -7. So -7, 5. Seeing some symmetry, that's good. Let's see, 0, -2. So -2, 0. 0, -8. Flip it around. -8, 0. Awesome. And that's it. Those are all the sections. Cool.